So as you're coming in, we need two things open. Well, three things really. You need Fiji, right? But then we also need you guys to open the slides that we're working with today because we're going to copy and paste code. So I wrote everything down there. So the slides are at imagej.net/presentations. It's scripting in Fiji slides. And then also download the example images. Those are the ones we're going to batch process today. Those are at workshops.imagej.net, which looks like this. You just need to download this zip file of 5. They're just 5 TIFF images of nuclei, DAPI stained nuclei. And just keep them in a folder, throw it on your desktop so we can access them easily. Because the goal today is for you guys to walk away with an example script that you can count and measure, do the measurements like we did yesterday for the segmentation protocol on a folder of images. That's the goal. It's workshops.imagej.net. Yeah. Oops. Everybody's got the slides open? Yes? Data downloaded? Yes? Okay, cool. We'll just wait another minute or two and then start. Hello. Okay, this is the last time I'm going to say this. So setting up for this workshop today, if you guys can just open the slides. They're at imagej.presentations, or imagej.net/presentations. I've written it there on the wall. Just open the scripting with Fiji. We're going to be copying and pasting code from those slides, plugging in Fiji to play with. And then also if you can download our images, like a little mini data set, those are found at workshops.imagej.net. The page looks like this. Just download this zip file and unpack it as well. And then just save that folder of images on your desktop somewhere easy that you can access them. It should just be 5 TIFF images of nuclei stained with DAPI. And one last time in those slides, when you open up that link, the scripting with Fiji, if you ever get lost, you can just move through the slides with the space bar. But if you get lost, you can just hit escape. And again, they're 2-dimensional slides, so you just navigate with the arrow key or just by clicking on a slide. Okay? And 2, we also have some helpers here today, so if you guys really need assistance, really just raise your hand. That's what they're here for. So Yili and Allison in the back, they're here to help. Because I'm going to have to keep moving through the workshop a bit because we're actually recording it today, which will be posted online. So you guys can always come back and watch the workshop again if there's something that you missed, so don't stress too much. The slides are also always available. You can always go back to and look at them. There's active links in all the slides, so it's kind of like a nice resource for you to go back again. But yeah, so we're videotaping this, but 2. So if you have any questions, I will try and repeat your question into my microphone. But actually, Allison, do you want to just hold this. So if you have a question, it'd be great if we could like record it. But if you really don't want to be recorded, just like tell Allison to go away and I'll just repeat it myself, okay? It's fine. It's totally fine. I get it. I'm not too excited about being videotaped myself, but hopefully this will be a nice resource for people outside of Madison. So I'd say let's start. Okay, you guys are all ready to go. You've got the slides open, yes? You've got the data, the folder with 5 images. Okay, so let's start. So I forgot to start yesterday by introducing myself. My name is Ellen Arena. I'm a postdoc with the Laboratory of Optical and Computational Instrumentation called LOCI here on campus. We are the maintainers of ImageJ. So you guys are lucky we're right here in Madison. Yeah, so let's just get started. Again, in back, we have helping today, Yili and Allison. So again, if you have questions, just raise your hand. They'll help you. So let's get started. So scripting with Fiji. So why are scripts useful? Well, they can help you document your work, right? So they can actually help tell you what you're doing and why. So you can really think of scripts, I like to think of scripts as kind of my lab book for computation. So you can actually see, by adding comments, you can actually write down exactly what you did and why. So the what you did is the code, and then maybe some notes and things, and the why you did it that way would be comments that you can actually write into your script. So you always want to think about down the road. You know, if I'm going to not only just pass this code or this script onto somebody else, one of my lab mates, but like think about your lab book, and in 3 months from now, can you read it again? Can you replicate it? So that's what you should be thinking about when you're writing these scripts, like commenting thoroughly and making things clear, okay? But of course, the reason you guys are really all here today is you want to automate this stuff, right? You want to automate your analyses. So you can run this code on multiple data sets, and then you don't have to actually click and do each step manually one by one on like potentially hundreds or thousands of images, right? That's really time consuming, so scripting helps in that. Also a great thing is that scripts can be shared. So again, like I said, not only just within your own lab or lab mates, but also with collaborators, or you can actually publish your scripts, right? So we can really make this science reproducible when it comes to image analysis workflows. Okay, so to kind of get started, we have this built-in recorder in ImageJ and Fiji called the macro recorder. So it can actually record each step that you're doing. One day, this process will be automatic, we hope so, but for now, like in order to record those steps into code, you actually have to open this window, this recorder window. So let's go ahead and just do that so you can actually get an idea of what it looks like. So again, we can use the command finder. So for those of you who weren't here yesterday, the command finder, you can actually just type L, and you get this quick view into the command finder. You can actually just quickly search for functions in ImageJ to run them. So in the command finder, the shortcut again is L or command L. We're going to just type in record. It's actually this record ... function. This will open that macro recorder window. Okay? And so you can actually record in different languages. So there's a drop-down menu in here, JavaScript, Bean Shell, Java, but we're going to be recording today, and all the scripting we're doing today is in the ImageJ macro language. So this language, it's not the most powerful language at all by any case, but it's really a good place to start in ImageJ, and particularly if you've never coded before. How many of you are in that scenario? You're not really coding a lot? Yeah, okay. So ImageJ macro language is really an awesome place to start. Okay, so for example, let's say I open an example image, blobs. Now you see, all I did was open this image. This is a built-in a sample image that's in ImageJ, and you can see the code for that is right here. The call for that code is run blobs, meaning open that image, right? So now if I want to do, for example, set a threshold. I'm just going to quick show you. You don't have to do this if you don't want to, just to show you that each step actually gets recorded. So actually, see? Now I'm even the toggles are recorded. But in our case, we don't want a dark background, so it should just be the default. And then let's say we would create a mask. So this is similar to the segmentation stuff we did yesterday. Boom, run, create mask. That's the code call. Okay? So this is getting a little messy because I toggled that button, but the idea is like each step that you do is recorded. But you have to open that window, okay, in order to record everything. Okay. So let's run that same segmentation protocol we did yesterday. I know some of you might not have been here yesterday, but it's really straightforward. So we're going to just start by going into Fiji. And I just want you guys to actually close the recorder for now, okay? Because we're going to just kind of make it non-specific for a particular image. So just make sure the recorder is closed. And we're gonna import one of those example data sets that I had you guys just download. We're going to do so using bioformat, so we're making sure we're reading in all the metadata correctly, okay? So again, in Command Finder, so again, that shortcut is L, Command L. We're going to type bioformats with a dash, bioformats importer. Okay, and we're going to open, now go to that folder where you have the images stored, and we're going to open number 5. Okay? You can in theory, you can open any one you want to, but then if you want it to look the same exact way mine does on the screen, open the C3-JW-30 minutes 5 underscore C5. And we'll just do the default settings. Open it with default. Okay, so now we've got our image, and personally I prefer looking at my images in grayscale. So I'm gonna just switch my LUT, and again, remember there's this shortcut button here on the top, LUT. I'm just gonna click it to grays. Again, you don't have to. This is just the way I like to work personally and to look at my images. Okay, so now let's open the recorder. So we've got our image open, so then basically we can apply that script to any opened image. I didn't want that hard-coded, okay? So open, again, the macro recorder. That's record ... And now we've got the recorder open, and we want to make sure we're recording in the macro language, right? So make sure that's selected. Okay, everyone's good so far? Yeah? And now we're just going to follow these steps on this slide, step by step. So it's exactly the same segmentation protocol we did yesterday, but we're going to automate this stuff, right? Okay. That's the exciting part of today. Okay, so the first thing we're going to do is apply a Gaussian blur. So again, in the command finder, we'll just type Gaussian, and we want this Gaussian blur ... And we're going to run it again, just the default setting with a sigma of 2. And you should see that single line of code popping up. The run Gaussian, so it's actually a run command, run function, that's calling the Gaussian blur with the default setting of sigma 2. And now we're okay to threshold. So we're going to threshold ... And actually, we need the dark background. So we might have to edit this script later on because of that little toggle. So make sure you have the dark background selected, and we're just going to, again, just use the default settings. So we're going to use the default thresholding algorithm, which is a form of Atsu in ImageJ, and then just the auto threshold. So now we're good to create our mask. So we're going to create our binary mask. So in the command finder, we're going to type in create mask. So we're happy with our threshold. And now let's create our binary mask. But remember, before we can actually count our objects, find our objects, create our ROIs, we want to make sure we have each nuclei basically as an individual cell, right, as an individual nuclei. And down in the corner here, we have some connecting nuclei, right? So they would actually be counted as a single object. So what we need to do then is watershed. So we actually need to split those two cells. So in the command finder, we're going to type in watershed. and run that. You should see those bottom two cells actually split. So now your code, the code that you have in your recorder should look something like this. Okay, so far. And now we can actually find our objects. Do you guys remember how we do that? How we created rows yesterday, any of you? The function that we call? Analyze particles. Called analyze particles. Analyze particles dot dot dot. So we get that guy going. We should get a window popped up like this called analyze particles. And remember, we have two things we can filter on: size, which is in pixels squared, and circularity, from 0 to 1, 1 being more circular objects. So for circularity, we're not going to touch anything. It's fine. For size, let's just create like a bottom threshold so we don't get any teeny tiny objects in this particular image. There aren't any, but just for learning's sake, let's set that threshold from 200 to infinity. And then we will only click this Add to Manager, so that's what actually creates the rows and saves them to our special row manager tool. And then we will exclude on edges, because we don't want to count cells that we only see part of them. We want to be able to really make sure we're only measuring and counting like cells that are completely held within the image. Okay? And then you run that. So basically what we just did is create a nice little segmentation workflow. So now we can actually save this code. We can create our first we call them macros. Macros is the language itself, but if you have just like a short little string of commands and stuff, people refer to that in the ImageJ world as a macro, right? Yeah. So we're going to create. So this create button is actually going to open up a new window called the script editor. And we're going to be using the script editor a lot today. So now we actually have our little macro. So it should be color coded. You should see things that are like yellow and magenta and green. And if you don't, that means a language hasn't been selected. Okay? So since we're writing this code in the macro language, we need to tell the script editor what language it should recognize. And so if you activate the script editor window by just clicking on it, you'll see a new menu system at the top that's specific for the script editor, right? It should say like file, edit, language, templates, run, tools. So if you just go to language and make sure you select the ImageJ1 macro language. So whenever you see text inside your script editor that's just black, like normal text, you want to make sure you select the language, right? And there's all different languages you can write in. So if you're familiar with coding and scripting, you can actually use the script editor to code in Bean Shell, Groovy, JavaScript, Python. Okay, there's a whole host. But today we're just going to focus again on the macro language. Okay, actually, I think I can increase the size of this so you can actually see it a bit better. And just remind me if I forget to do that. Okay, I do that a lot. I forget if I open new scripts. But it's easier for you guys to actually see. Because we're going to just make a couple little edits in this, since I had to toggle that default dark background when we were thresholding. So we want to have a dark background. So actually I'm going to edit the second line so it looks the same as the fourth line, right? So it should be set auto threshold default dark. And then since we called it once, we can just get rid of the second call and delete it. Okay, so your code should look exactly like this. And if it doesn't, you can just edit it directly. You can just type and edit it directly in the script editor. So I'll give you guys a minute to do that. So make sure it just looks like this. 2, from the recorder, I just have like a word of caution. We actually hit the create button, right, to like save that code and pop open the script editor. We don't advise that you necessarily copy and paste. There were issues anyway a little while ago where there were some bugs that were being introduced with copy and paste, which is why we recommend now clicking this create button. But I mean, obviously you can copy and paste single lines of code as you're building up a workflow. But just keep that in mind. If something's not working, just double check that what's in here matches what you recorded, right, as far as the functions go. So everybody's got the script looking like this, pretty much? Okay. We just created our first macro, guys. It's a big deal. It's exciting. It's the first step. But now we actually can like spruce it up, make it a little bit more fancy, right? Because right now it's kind of humdrum and it's not actually going to work the right way because we haven't measured anything yet. Okay? So we're going to actually, first, I'm going to give you a little teaser into script parameters. So script parameters, we're going to talk in more detail in a minute, but just for now, we're going to add a script parameter into this. Because remember how I set this bottom size threshold to 200? Let's say you want to give this script to a colleague of yours, and you want them to be able to select whatever size they want, like a minimum threshold of any value they want, right? You want that to be flexible. So we're going to actually use a script parameter in here to ask the user for an integer. So these are a little bit weird because they're actually hidden in comments. So just bear with me for the moment. So we're actually going to type this, if you can follow along with me. Can you see that well enough in the back? Do you want it bigger? You guys have good eyes. Okay, it's fine. So we're going to use this at call for an @int, which is telling the system what type of script parameter it should be. So in this case, it's an integer. And then we're going to add a label that will actually tell the user what you're asking them for, right? So we're going to ask the user for a minimum size. And then whatever number they type in, we're going to assign that value to a variable called min size. Now don't freak out so much about like the terminology I'm using with these variables and blah, blah. We're going to go over all this stuff stepwise, okay? So what's cool now is that we've pretty much in the script have asked the user what minimum value they want to use, but now we have to actually write that into our code, right? Because right now it's hard-coded as 200, but we want this number to be flexible, right? So what we need to do actually is break up this string, and what we do is a concatenation. So we're actually going to concatenate our number into that script. So we delete 200. So essentially you're just inserting the number that the user selects into this string by calling this variable that we named at the top, min size. You can call that anything you want, min size. You could call it bubblegum. I mean, we are calling it min size because that's informative, right? So later on, if we read the code, it gives us a clue as to what is contained within that variable. So now your code should look something like this. Okay? So now we can actually run this. So what I'm just going to do is close out these other windows. So like the Roy manager, all this stuff, we're going to be closing them because when we run the script, they're going to reopen each time. So, sorry, just get used to it. We're going to also close the recorder. And we're going to open that raw image data again once more with the bio format. So you're also going to get very familiar with reopening quickly with bio formats, importer. So just open that same image again with the importer. And if you really want to be smart, you can actually duplicate this guy and just save a copy or a couple copies of the original data just in the background. It'll just kind of be faster in the end. So that's what I'm going to just quick do is duplicate this. Again, to duplicate, you can either type into the command finder, duplicate, and it's duplicate ... Or you can run like the shortcut, which is Shift Command D, just to duplicate it. But you don't have to. I'm just going to do it because it's a little bit faster. So now when I run this, see we get this window that pops up. That's what the script parameter did, this guy at the top. So it's it's building this little GUI to ask the user what minimum size do you want to set. So now the user can set this to whatever they want. They can just move these up or down arrows or type in a value and can change it. And then the script just runs. It doesn't look like mine? Just raise your hand because we've got Yeely and Allison in the back. Okay, so again, I'm just going to close the Roy Manager and the mask that's created. A lot of windows end up popping up, right? Not save, and then I'm going to duplicate this again. So now I just have two original images, like copies, and the script editor open. But you saw how powerful that is to write. Just this one little line automatically just pops up this cool little GUI that you can interact with the user, right? And there's tons of different types, so we'll talk about that too, script parameters. But now we want to generalize the script just a little bit more. And we actually want it eventually to be able to like measure on the original image, right? Like we did yesterday. So we're going to add some code in here to actually get the ID of this image, the original image. So we're going to call it ID, or you could even, if you want, call it like original image. That's probably more informative than ID. Original image ID. And we're going to call this function get image ID. So basically we're just going to save the ID of that original image so we can come back to it and actually measure from our ROIs off the original image data set again later on. And then what we're going to do is run duplicate. So we're going to work on our duplicate image just like we did yesterday. And there should be a space between these quotations. Now this part of this call is just to name that duplicate, so you could name it something, but I just left it empty, okay? And don't stress too about, oh my God, how am I gonna remember, like she's just writing the code out and like, how am I gonna, you don't have to. You've got the recorder, right? You've got the recorder. And I'm gonna show you a cool place where you can like search for the built-in functions in ImageJ macros language. So you can always just have that page open and record stuff. Just do it, record it, copy, the code. And now at the end, what we're going to do is just like yesterday. So remember we did our analyzed particles, we basically created our ROIs over the mask, but what we want to do is overlay those ROIs onto the original image at the end and then measure. So that's what code we're going to write down here at the bottom, okay? So we're going to actually clear results. So this is just in case there were previous measurements done that were in the results window. You just want to like empty it, make sure it's empty of anything before we measure. So then you're just getting the measurement from that one particular call. And then we're going to select our image, right? So we want to select our original image again. And we called it original image ID. See here, up here on line 3, we named it this variable. So we want to actually select that image, so we just have to say original image ID, and make sure you just type it the same, right? Variable names are case sensitive. They are case sensitive. So now, just like we did yesterday, I'm sorry some of you weren't here, if you want to overlay ROIs, so you've got them saved onto your manager, you just have to activate the image you want to overlay them on. And there's a button in the ROI manager called show all. So it's basically just toggling that button, which will overlay the ROIs. So that's exactly what we're going to do now. We're going to do a ROI manager call and toggle that show all button. And we'll do it with the labels because then they're numbered. Okay, so what we did was just, we moved from the mask where we had our ROIs activated. We moved over to the original image, and now we toggled our ROIs on top. So now we can measure. And to be safe, to make sure no ROIs were selected, because if you just select one or a subset, it'll only measure those. So what we want to do first is deselect, just to be safe that we don't have any individual ROI selected, because we want to measure everybody. So we'll do a deselect and another ROI manager call for measure. So again, if you're doing this manually and you have that macro recorder window open, all these calls will be recorded in there. So you don't stress about memorizing the code, okay? Trying to make your life easier in this respect. So this is cool. We actually just generalized our script a little bit more. So now when we run this, got our original image. I just deleted the duplicate because we're going to create a duplicate, right, with our code, and we run it. So our minimum size, I'll just go back to 200. Yep. So now we actually have our mean values over our original image. So it did the measurement on the original image, just like what we wanted. Do you want to see the code again? Yeah. And don't stress too much too, because all this code is also written in the slide. It's unfortunately right now it's really tiny in the slide, but it's there, right? So you can always go back to the slides later on. If something's amiss right now, don't stress too much. You can always go back, and you can watch this video presentation again down the road. Okay? And then we're going to add one more little line of code that's going to kind of make our lives easier, especially when we're talking about batch processing, files of images, folders of images. So I'm just going to go back and close everybody except for the original image again, just individually, and I think the results window as well. Yeah. So I only want 2 images open again for now, just the script editor and my original data set. And I'm going to add a line at the top, not at the very top, but I'm going to add a line called set batch mode to true. Because we're happy with this workflow, right? It's working, we're running it, you're seeing all the different windows pop up. But obviously, if you're processing hundreds of images, you don't want all these intermediate windows to be popping up all the time, right? Like the mask, and then like the ROI manager, and the analyze. Well, I think the ROI manager might still pop open. We'll have to see. So what this does is just like stops the windows from opening, right? So we just run in the end, and we should just get our results window. Maybe the ROI manager. I don't remember. We'll have to run it and see. So it's that command is set batch mode true. So again, we select our minimum size. Yep. So now we don't have to deal with all those extra windows popping up. We just have our streamlined code. Because this in the end is what we want, right? But so normally when I'm writing my scripts and stuff, I'll have that set, I usually just add that set batch mode to true written there, and what I do is just keep it commented out. So now it won't be read in, right? So now if I run it again, all the windows will pop up. I just wait to actually run that code and use that set batch mode to true until I'm happy at the end, like everything is looking as it should, right? So you can look at each step of your script, pretty much, and then you can uncomment it. Okay, so let's say, is everybody good? We have mixed faces. We have happy faces and sad/scared faces. I don't want to see any scared faces. You should all be smiling, because this is awesome and will really help streamline your science, right? I'll just leave this up here for a minute. But what's cool, let's say this is a script that you find really helpful. Like, I know I'm going to acquire my images and use this in like the same way and use this script a lot. Or like I want to, you could maybe have individual adaptations, but I want to save it, and I want to save it into my plugins folder. So what's cool is that you can actually add this to your, so if you activate the main window for Fiji, you have this plugins drop-down menu. But remember, we kind of avoid the drop-down menus because we're using that command finder, that search quick function. But we can actually add our own scripts into this drop-down menu, and therefore we can search for them with the command finder. We just name them whatever we want and save them in here. So I'll just quickly show you guys how to do this. You can follow along if you want, but if you get lost, don't stress again. You can always go back and rewatch this video. So what we're going to do is actually save this macro. So just activate the script editor, and we're going to save it as, I'm going to call it nuclei count.ijm. So when you're saving these macros, there's a rule of thumb that you need an underscore in the name. Okay, that's just this like unwritten rule. But I believe it's kind of written because I put it on the slide. Yeah, here. You use an underscore for spaces in your macro. So I called my nuclei underscore count, and then you have to actually declare the language, the file type. In this case, the ImageJ macro language is a .ijm file. Okay? Like or Python is .py. Right? So this is an ImageJ macro, so we need to add on that IJM file. And what we're actually going to do now is navigate to our Fiji folder where the actual software is stored on your system. So this is a Mac, sorry for Windows users, but I'm more familiar with the Mac. So just go to your applications folder or wherever your Fiji is stored, and we're going to actually open it up, open up that package, and there should be a folder called scripts with an all small case letters, scripts. So we're going to go in there. So again, we went into our Fiji package. There's a folder, there's a bunch of folders, like jar folder, plugins, scripts, but we want the scripts because we're working with our script editor, think scripts. And I'm going to save my script. So within that scripts folder, you actually need to create a new folder called plugins with a capital P, because this way the system can actually like find it and read it in, and then it's searchable. It'll pop up in that drop-down menu and be searchable with the command finder. So you create another folder, a subfolder in the scripts folder called plugins with a capital P, Plugins. And now within that folder, we're going to save our script. But you can also save subfolders here. So if you know, like, you've got a group of scripts that kind of do similar things, like you're working with, like, I don't know, in vitro cells, like in vitro scripts, you can do another subfolder and, like, kind of group them together in the drop-down menu. So you can do in vitro scripts, in vivo scripts, things like that. But for now, we're just going to pop them in here and save. Now, it's not going to magically appear now in the drop-down menu because I actually need to restart my Fiji and reopen it. So I'm going to close it and reopen. And now when I actually go to the plugins folder up here at the top, I should see my nuclei count right here at the bottom. It's right here. So what's cool too about that is that if I have my image open, so I'm just going to select, oops, sorry, wrong thing. Try that again, bioformats, importer, and open that sample image again. So now we know that it's hidden in that plugins folder, right? So I'm going to just go to my command finder and type nuclei, because I called it nuclei count, and run it. Script runs. So yay, it's good. So I would recommend though, because there's lots of issues sometimes where you have to like uninstall and reinstall your Fiji for whatever reason if there's bugs and stuff. Just make sure you always save copies of your scripts in separate places, right? Because you'll lose all that stuff in that scripts folder. So I wouldn't only save them there. Save them there if you find it handy and you want to like be able to. If you want to be able to actually like search in the command finder, just run it automatically. Save a copy in there as well. Have your actual scripts saved somewhere far away from those folders in case you need to uninstall and reinstall Fiji. Okay. Okay. Okay, so again, like I said, you can always go back to these slides, and the code is written right here in this tiny little image, so you can actually recreate that same exact script if you want. If you didn't get it to work today, you can always go back. So the script editor, Okay, we're just going to do a little sideline here. So the script editor, we were just working with it. It's more than just like a normal text editor, right? It actually helps us write code because it's syntax highlighted, right? We have this colorized version. So the color indicates the different pieces of code, like what they mean. So if actually, there's also a handy shortcut. So if you've got Fiji open and you want to go straight to the script editor, you can, I think, type script. Oh no, you can't type script editor. I don't know how it's saved in here. Actually, so you know what? We're just going to use the shortcut, which is just the left bracket key on your keyboard. I don't remember what the search is in the command finder. That's embarrassing. Because I always just use the left bracket key to quick pop it open. Okay, so if I open an example code, so you'll see that it's syntax highlighted again, right? I think I was kind of hinting at that. So green, the green color indicates that it's comments, right? So they're not technically read in by the system, except in the case of script parameters. Those are an exception, a very weird exception, which we will go over in more detail later on. Functions are this kind of yellow color. Strings are in this kind of magenta. Numbers are in blue, I think, in the end. So again, if you don't see that colorization, you need to just make sure you activate a language here. Okay? So actually, I've been using a lot of terminology today. So let's just go over some basics. So for those of you who have scripting knowledge, this might be a little bit dull, but we're just going to go over some of the basics. And we're actually going to be copying and pasting. You can actually like go in the slide itself. We're going to copy and paste this code and put it in our script editor. Okay? So just go in. So we'll start with the comments. Just highlight it all and copy it. I'm just going to delete this and actually just paste it in here. And again, if it's not colorized, what do you have to do? Exactly, select a language. So in this case, we're always going to be using all of this stuff is in ImageJ1 macro language. So comments. Comments allow you to put human readable thoughts into your code, right? Code is inherently tricky to read. That's why we call it code, right? I think that's funny. Okay. Anyway, so that's why we use comments, because we want something that's actually readable and digestible and kind of explains what we're doing and why, right? It's the same thing as if you have a written protocol. Today I added more buffer. Well, why did today you add more buffer and yesterday you didn't, right? You would indicate that in your lab book, right? So the goal of this macro is just to like teach you a little bit about comments. And you can pretty much write them anywhere. So for example, a lot of times you can write them on single lines. For example, if you want to describe your macro code in the top, but you can at each line actually after you run you run code, you can actually put the comments behind. Code can also be disabled by commenting it out, which I find really helpful if I'm editing scripts and stuff. Instead of deleting things, especially when you're learning, because you don't know, you might want to go back to that code at some point, you can just disable it with comments. So now this code is recognized. You can see the syntax highlighting. But if I don't want to run that code, I can just put 2 backslashes in front. So the comments are, in this case, are indicated by the 2 backslashes. I should have said that first, but I didn't. I saved it for the end. Okay. But again, script parameters are a really weird exception. They can actually be read by the system, despite the fact that they're hidden in these comments. Okay? But we'll go over that in a minute. So next slide should be variables. And again, if you get lost, just hit escape. Because now we're in a 2D part, so just go down to the variables, and let's just select all of that guy and highlight that. Copy and paste it. Just over this other stuff, it's fine. Oh, I could make this bigger again. So you guys need to remind me. I'm really bad at remembering to increase the font size when I copy and paste, so just remind me. So variables. So a variable is really essentially just a placeholder. So in code, we use it to actually assign variables. We use this equal sign, right? So this is actually, it's not the same as in math. It's an assignment, okay? So in the macro language, there are only 2 types of variables. There are strings and there are numbers. Because even Booleans, so yeah, true or false, yes or no, are numbers, okay, 0 or 1, right? So all we have to deal with are strings and numbers when we're talking about variables. So for example, like if we run this code, let's just stepwise. So first the string, we have this string called hello world, right? And we're assigning that value, that string, to this variable called title. And you can do that again with numbers. So numbers in this case, value is 255. We're assigning that value, that number, and we can distinguish them, especially the syntax helps, right? Because strings are pink, magenta. Numbers are this purpley blue. And we're going to assign that number value to this variable called intensity, right? So that's its new name. Intensity holds the value 255. And now if we actually run this code, I'm just going to quick show you that an error pops up, and it says there's an undefined variable in line 5. Okay, well, it's actually line 4, but so it's actually highlighting it for us. It's the first variable comes upon that hasn't been actually assigned a value. It's x, right? We didn't say above this line of code what x equals, so it's not actually able to do the math, the expression on the right-hand side, right? We need to declare the value of x before we can actually use it. Okay, so that's all that's showing us. Okay, so I'm just going to highlight that out for now. So a string constant versus a variable name. Okay, so what we're going to do is actually add some print statements to help us kind of figure out what's going on with this. So in line 8, we're going to type in print, and then we want to print out the variable text. Okay, so what do you think is actually going to get printed out when we run this? So we're calling this function print to print out what variable is held, or what value is held in this variable, which should be what? Title, exactly. So if you run it, you see title. Because we're printing out that string. We're printing out what the variable is pointing to. So if we actually add another print statement at the end here now, we're going to print text again, but we're doing something different here on line 9, right? We're assigning the value that's held in title, the variable title, we're reassigning that value to text, this variable text. So what do you think will be printed the second time we print text? We're reassigning it, its value. Anybody? Hello world, exactly, because right at the top, line 2, we actually assigned the variable title the value hello world, right? We declared the value of text to be title, but now we're reassigning it. So whatever was held in title, we're going to put it in text. So if we run it again, we'll have, first it was title, now it's hello world. Okay? Okay, so instead of deleting these print statements, I'm just going to comment them out for now. And again, we're going to do, it's a similar idea with integers, right? So we're going to assign this value 3 to x, the variable. And when we print x out, should be obvious what will be printed, right? 3. 3 is 3. X is 3. And now we're actually going to assign whatever value is in x to this new variable called y, and we're going to print out y. So what do you think will be printed? When I print x the first time, we assigned it 3. Now we're saying whatever is in x, assign it to y. So when I print y, should print 3, right? But it's important to actually realize that these variables aren't linked, okay? When you assign the value in x to y, x and y are just two separate variables. So now what we're doing is changing the value of x at this next line of code, right? So if we print x, its new value is 5, right? So we should get 3, 3, 5, right, our new value. But now, if we print y again, that's independent of changing the value in x, right? So it actually should still be 3. And it is. Just because we reassign the value of x here at this line at 16 doesn't have any effect of the assignment we gave y previously. We'd have to reassign a value again to y. Okay? And again, I'm just going to comment out these print signs. And then the last line, so the variable is assigned after the expression is evaluated. So we actually assign this variable intensity way up at the top here. We assign the value 255. So what it does, it'll carry out the expression on the right-hand side first. So it uses this value 255 and this variable intensity. So it'll do 255 times 2 and then reassign it to intensity, right? So if we actually print out intensity before we do this expression, so you can actually say like before, and now we're going to print out intensity after. You can also just print out intensity. I'm just doing this because it's easier. So after expression, well, we can just say after. They should be 2 different values, right? Yep. So before we do it, before we run the expression, it's 255. Then after, we do what's on the right-hand side, right? We do the expression and then reassign it to that variable. So now intensity has a variable value of 510. These are just things to keep in mind when you're working with variables. Okay. And next we're going to move on to functions. So functions should not scare you because we've been using them. We've been using them this whole first part of the workshop so far. But like print is a function. You're calling a function, right? There's all these built-in macro functions. So this link is actually really helpful. If you open this, you'll see these are all the built-in macro functions that all the goodies that come. So like, for example, you want to, let's say, like look at what set batch mode, because we used that one before. So you can actually search for your functions here. If there's something you want to look for, like how to open an image, and then what are the different functions that you can use. Set batch mode, it basically will have the call, like how the function is called, and it gives you an explanation of the arguments that you need to put inside. Okay, kind of explains. It's a good place to start. So this website is really helpful. So just follow that link there at the bottom. We can also search the wiki for built-in macro functions, the imagej.net homepage. So functions, let's again copy and paste this code into our script editor. And for now, we're just gonna go stepwise, right? I'm just gonna comment out those 3 bottom call functions, function calls. Say that backwards. So again, right, our function here is yellow syntax. So the function we're calling is print, and the arguments we're putting in that function are hello world. So print out that string, right? So when we run it, we print out hello world into the log window. You can also use them to actually return values. So this one in particular, get number. You can actually search for this in the built-in macros website and kind of gives you that explanation. So I'm just going to search for it here. Get number. So then it says it displays a dialog box and returns a number entered by the user. So kind of similar to that script parameter we used before. The first argument is prompting the message. So we write our message right here. And then the second value is just the default that is initially displayed, right? So that's essentially, this will tell you like how to actually use these functions in your scripts. So again, we have this get number. So we say this is the message that gets printed to the user. Type in a number. And for a default, for the first time it runs, it just plugs in 5. But we can change that. It can be anything you want, 10, 100, whatever. So when we run it, our little window pops up, and it prompts the user for a value. Okay? And now we're going to actually run the duplicate function, because that's one of my personal favorite functions. I run it all the time. So let's open an example image. So in the command finder, again, the shortcut for that is Command L or just L. Type in blobs. We'll open that image. Actually, we'll just run the first duplicate first. So I'm going to comment out that bottom one. So again, you can search for this run function in that built-in macros function website. So when we run this, it's actually going to duplicate the image and then assign it a title. And it's going to be called new. Okay? So when we run this, you should get another window popping up of blobs. And at the top, instead of blobs.gif, it should say new. Okay? And you can name that anything you want. The only caveat is if you actually have, if you want to include spaces in the name, then you have to use this other format that encloses the string that you want to be the name of that copy within brackets. See how that's different than the upper one? So like, for example, if we leave that on, and I say with spaces, without the brackets, right? We've got two here. So I have a duplicate call that says with spaces, no brackets, then a duplicate call with the brackets. You'll see that one image will be called with. So it drops off the spaces. As soon as it sees this space, it's done. It won't read it anymore. So if you want to include spaces in the title of your image, you need to include it, enclose it within brackets. Okay? Pretty straightforward. Okay. Now strings. We've actually been using strings a lot, so this should be pretty straightforward again. So I'm going to copy and paste that code into here. So again, we're doing a variable assignment here at the top. Saying the string copy, we want to assign it to the variable called name. Actually, before I do this, I'm going to just comment out these run functions. So you can concatenate strings. So I've used that term before. You can also concatenate strings and numbers together. Then the numbers will be considered a string as part of the string. Okay? So if you go ahead and actually print text, because we're doing this concatenation, we're calling this variable here and tacking on what is held inside, the value inside this variable onto this string. What should it print out? What should be the sentence that's printed? The name is copy, exactly. So if we run that, we'll see, boom, the name is copy. So that's our new string because we concatenated another string onto it. Okay, so this is exactly like what we just did with these run duplicate calls. So we're pretty much doing the same thing, right? When we run this, so actually it's showing you the difference between a string and then the variable name, right? So right here, you can see actually the syntax colorization kind of tells you what will get printed as the name of the copy. So when we run this first duplicate call, we're going to retitle it, but what are we going to call it? What's going to be the name that's printed at the top? So look at the syntax highlighting the colorization to give you a clue. We're not actually calling the variable here, right? We're actually telling it to use the string name. It's a little bit confusing, but that's why there's syntax highlighting. Kind of gives you a hint. The second call actually is using the variable, right? In this case. In this case, we're actually, because we're doing a concatenation, and we're calling this variable. You can see it's dark, right? It's black print. Also gives you a little bit of a hint. So then in that case, the second duplicate should be called the value that's held within that variable, which is copy. And that's exactly what we see. The first duplicate is called name, because that's just using the string. Like this could be bananas, right? It's just going to see it. But in the second one, we're actually concatenating onto the string the value that's held within this variable, name. And in that case, it's copy. Okay? Okay. Conditionals. So let's copy and paste this code. Whoop. So again, here at the top, you'll see right away we're using that at syntax. So we're actually calling a script parameter here. So we're going to prompt the user, instead of asking them for an int, an integer, a number, like we did last time, now we're asking the user for a string, so a word. And we're going to save it into this variable called instructor. And we're calling that variable down here below. So a window's going to pop up and ask the user for a string, for a name. And then what we're doing is a conditional. So if this instructor is going too fast, so basically this get Boolean call, again, you can search for this in the built-in macros function. So get Boolean. It will display a dialog box containing the specified message, and then a yes, no, and a cancel button. Okay? So it's going to return true if the user clicks yes. Makes sense. It's going to return false if the user clicks no. Also makes sense. But then if the user clicks cancel, it just dumps out of the macro. Okay? So that explanation is right in here. So what this is doing is trying to get, so if this condition is true, it's going to do the code that's within this block, within these brackets. But if it's not true, if what's up here is not false, or is false, so this is the if-else statement, it will then, instead of doing this code, it will do this bottom set of code. Okay? So if you run this, so let's say the instructor isn't me, let's say it's Bob. Okay? Because that's the string parameter call for the script, or the script parameter, sorry. So now we get that dialog box, right, for the get Boolean function call. So is Bob going too fast? Let's say, if I click yes, he's going way too fast. What code will actually run? Tell them to slow down, right. So we're going to assign this string to this value hint and then show a message that should say that hint. So he should say, tell them to slow down. Okay? If we run it again, now this time for Bob, we say, Bob is going too fast. No, he's good speed. In fact, maybe he's a little bit slow. So then what you can do is, boom, try to modify the code and play with it. Okay, so it's just a way of separating out two different conditions depending on what you want to do. Checking the state of something and then doing things regarding that state. You can also tack on other if clauses if you want. So for example, if this is true, then you'll do this code. But let's say we want to do another else if statement here. So else if the instructor's name is Ellen, so if it's me, I want you guys to do something very specific, right? And I want the hint to be, give her a high five. I need reassurance. Okay? So now what we're going to do is, so if this is true, it's still going to tell the person to slow down, right? But if what we're doing here too is we're asking if the instructor, the value that's held within this variable instructor, if it equals Ellen, so if this statement is true, that's the double equal sign, then the hint will be give her a high five instead. Okay? So if we run this, we're not going to give Bob a high five because Bob isn't Ellen. So if we type in Ellen, is Ellen going too fast? No, she's not going too fast. So then give her a high five. She's doing a great job. Okay, so then that's the code that actually gets run in that case. But if we said yes, she is going too fast, it'll still run that first block of code. right? Tell them to slow down. So you can actually chain your if else, if else, if else, else statements, okay? I think I added another else at the end, but you know what I mean, if else statements. Okay. And loops. Loops are super helpful. So let's copy and paste that code. Tack it inside. So there's two main types of loops that you can actually use. At least the two main types we'll touch on today. You have a for loop and a while loop. But really, essentially, they're kind of doing the same thing. But for loops are structured in a way that they have an assignment section, a test, and then an increment. And these you usually use for loops when you know the number of times you want to like do a block of code. Okay? So for now, I'm just going to actually comment out the bottom loop, the while loop, just so we don't have any extraneous stuff popping up. So for this loop, for this for loop, like I said, we first have an assignment. So we say when we'll start with I equals 1, okay? You can really set it to any start value you want. As long as now we'll do our test section. So as long as I is less than or equal to 10, we'll do the code that's inside the block, inside those brackets, okay? And when we're done with that code, then we'll increment I and keep going. So now I should have the value of 2, right? So this plus plus just adds a single integer on. So now I equals 2. 2 is still less than or equal to 10. So we'll end up doing this code again and then increment. So I is 3. So if you actually run this, you'll see it print out, and it runs 10 times, 1 through 10. Right? And if we actually change this value to be like less than 10, it'll only count up to 9, right? So that's just the syntax for that. So my question to you is, I at the end equals what? What should a value be at the end of this loop when we're outside the loop? What is the value of I? 10? Well, the great thing about code is that we typed it in here, so we can just run it and see, right? But unfortunately, the answer is not 10. It's 11, exactly, right? Because at that end, you had I was 10. 10 is equal to 10, so you print the counter I equals 10. I is 10. Then we increment, right? So then it's 11. I equals 11. So it still has to do this test one final time. So is it less than or equal to 10 if the value is 11? No. Then it doesn't do the code. So the final value of I after this loop is 11. Okay? Okay, so for the while loop, so now I'm just going to comment out those print lines and uncomment our while loop. So while loops are handy when you don't necessarily know the number of times, the set number of times you actually want to run this code. It's a conditional kind of thing again. So while a thing is true, keep running this block of code. As soon as it's false, stop. Don't do it. Okay? If it's false, stop. So again, we're using that get Boolean function. So it's asking the user for that, asking them a question, gives them a no, cancel, yes option, right? So if I click yes, it's going to return true, right? So then what will happen? I want it to keep going, so I want to click yes. So that means it returns a value of true. So it will actually print out that code inside of the while loop, right? So I say yes. Do you want me to keep going? This is just an endless loop, right? As long as I keep saying yes, it's going to run that block of code inside. Okay, I'm still going. Okay, I'm still going. Okay, I'm still going. And as soon as I want to dump out, that statement that after the while needs to be false, right? So then I have to say no. and then it dumps out of that loop. And then you get a little message prompt that says, okay, I'm done. No more print statements. It's done. Okay? Okay. We have one more little macros tying all this basic coding stuff together, and then we're actually going to batch process stuff. Okay, because that's why you guys are here. So one last example. Let's highlight this, copy and paste it back into the script editor. And for this code, you do need blobs open, because we're going to run this example code on blobs. So don't panic too much if you don't quite understand exactly what's happening with this duplicate and selecting and adding slices and stuff. I'll just walk you through this code. The idea is to still get this idea of a for loop and the variables that are being called kind of ingrained into you, because there's actually a problem with this code. Okay? So what we're going to do, this code basically makes a stack of blurred versions of the original image, given a range of radii. Okay? For this, it's like a Gaussian. I think it's applying a Gaussian. Yeah, it applies a Gaussian. It's just changing that sigma value. Okay? Like we had ours set to 2. So what it's doing is it's asking the user for what they want to be the maximum radius, and in this case we'll just use 5. Right? This is just the default, but we'll just use 5. So what it should do is then tack on, up until that value, a slice incrementally, so each time, so a total in the end of 5 slices, and each one should get an increasingly large sigma, so the blur should get like kind of larger and larger as you're increasing the radii size. So if you guys want to just open blobs and then run this, and leave the maximal radius at 5 for now, because it's just, otherwise we could create like giant images. Okay, so this is the result. So if you just step through these slices, do you notice anything? It should be getting more blurry incrementally. You can zoom in as well if you want. Just put your cursor over the image and zoom in and out with the plus and minus signs on the keyboard. Like personally, I don't see anything changing as I'm moving through these 5 slices that have been tacked on. Right? So let's look and see what's happening. I mean, the changes should be occurring in the for loop, right? So we actually let's see what's going on here. Let's just focus on the for loop for now. So we're saying, okay, we're setting I to equal the value of 1. This all makes sense so far. So as long as I is less than or equal to the radius, we do this code, right? And the radius we set at the top, right, by the user input at the top line here. We said whatever value the user types in, that variable radius, it'll be assigned that value. So ours is 5. So as long as I is less than or equal to 5, we do this code, and then we increment. But you see here, we have this, the issue actually comes up here with this call, this Gaussian blur. Do you see the issue? Each time we run through the for loop, we want that value to change, the sigma to change, or the Gaussian blur. We want it to start at 1, then go to 2, then go to 3. But if we actually look at our result, we see a blur is applied, and then nothing's changing. It's applying the same blur each time. And that's because we're actually calling the wrong variable here. Okay? We're calling radius. That's not what we want to plug in here. What variable do we want to be added here? I, exactly. We want the incrementing variable, the one that's changing as the for loop is being called. So a lot of the problem that comes in here too is just the naming of the variables in this particular example is kind of weird and like confusing. And there's like a simple fix that we can do actually is just rename our top variable. It makes more sense, doesn't it, to call it max radius? You can fix this many different ways. You can leave the variable names too and just change that to I. But let's just make it a little bit more readable. So let's call it max radius. So now in our for loop, we want to make sure the maximum value we use is max radius as well. And now instead of using I, we can actually just use radius, because those are the ones that are going to change as we go. So you just got to make sure you find them all. and that you spell them correctly. Again, it's case sensitive variable names. So once your code looks like this, you can run it again on blobs and see what changes now. Should run correctly if I did my job correctly. So let's run this. So maximum radius, we'll just keep it 5 again. And now when we zoom in and we move through the slices, we can see that's exactly what we had intended. It's getting a larger and larger sigmas being applied. So far it's getting blurrier and blurrier as we move. Okay? Okay, let's move on because we got to get to the good stuff. Not that this isn't good. I think this is very helpful, and you will find this helpful later on, but let's get to batch processing. Oh, first, script parameters. Silly me. Let's talk about script parameters. This is just like, you guys have had enough of an intro. You kind of get an idea of how you can use them in your scripts, right? But we have a template here that you guys can actually use. So if you actually go into Fiji and open your script editor, again, you can just use the shortcut, which is the left-hand bracket. And then templates, where was it again? Intro, thank you. Templates, thank you very much. Templates, intro, and then it's these widget examples. And you can use either one. One is written in Bean Shell, one is written in JavaScript. For script parameters, the great thing about script parameters, they don't care what language you're typing in, right? You can use them for any language you want. So for macros, JavaScript, Python, blah. So just pick one. And we're just going to focus on these top 24 lines for now. Okay? So the cool thing is about this template example, you can actually copy and paste these guys and start using them and applying them in your own scripts. So script parameters, again, like I said, there's 5 different types. So you've got checkboxes, so like Boolean. So if you run this, actually you can see each one of those 24 script parameters actually you get an output here. So you have a Boolean option, which is just pretty much a yes or no, right? True or false. So in this case, it's displayed as a checkbox. Then you have different numbers, number types, and characters or strings. You have bounded integers, so you can give a range. A bounded integer would say, I only want the values to be in the range from 0 to 1,000. So that's a bounded integer. You can also give lists of strings. You can use the this @file annotation says it's a file type, so you can basically browse your system then. You can get a color wheel for the @color. So pretty much the syntax is like the type of the thing, so like string or int or Boolean, and then you give it a variable name. Okay? But there are other things you can play with too, so there's different kinds. Like for example, for this bounded integer example, so where is that guy? That's line 17. Okay? We're going to just add a style to that one. Because actually if you run it and you look at bounded integer, you just get this like up and down menu, which isn't really helpful, especially for bounded. Like we know we want it to be from 0 to 1,000. It'd be more handy to have like a scroll bar. So let's add that type. So you can actually add that style, and the style is just called scroll bar. So now when you run it, so it should just tack on this style scroll bar on the inside of that, follow, like a comma should be in there. This is the new code you're adding to that bounded integer. So now when you run it, you get a scroll bar instead, which is a little bit more handy. 0 to 1,000. Okay? 2 for like strings. Right now we didn't call, it just had like a default that was in there. So if we actually want to give the user choices, like we want to limit the number, the strings that the user can choose from, we can add choices like this. So we actually use the curly brackets in this case. So we can say like they want quick fox, they can choose from quick fox, lazy dog, like silly fish. and then enclose it again within a curly bracket. So then what's cool is that in that string now, you actually get a little drop-down menu with the 3 options if you need to limit them somehow, okay? And you can search for script parameters on the wiki on imagej.net, and you can read up about all these different options that you can do with these types of guys. 2, for example, there's one for a date. So if you need to choose a date on a calendar, the @ type is date. So if you run that, you'll see the interface pops up like a normal little dialogue, what you would get to choose a date on the calendar. What's cool though too is that we include these templates, these widget templates, and you can copy and paste this stuff and just start using them and playing around with script parameters. Just as a much cleaner, faster way of interacting with users, making things a little bit more robust, applicable. 2, I'm just going to say 2, I forgot the most important thing. When you're using script parameters, right, they're a little bit weird because they're hidden in these comments. The rule of thumb is that they actually have to be the very first thing at the top of your script in order to be read correctly. So for example, if I had put a comment here above that says, this macro explains script parameters, well, it's not going to work now. I don't think it should not work. Nope, it doesn't work. So it won't actually render these guys. Now it's considering them part of the comment section. So in order for them to actually be read into the system, they have to be the very first thing at the top of your scripts. That's all you have to remember, really. Then you can put more comments below them, it's fine, just as long as they're at the top. Then they get read in. Okay? Okay. Okay. So what you're all here for today is batch processing. So there's 2 different ways that you can batch process things in ImageJ. You can use this built-in feature called batch process. It's pretty easy to use. Like that's what I started using when I first started batch processing stuff. If you just have like little macros, like little lines of code, simple things, nothing too fancy or interactive like we did before. That you just want to like boom threshold a bunch of images, or I just want to apply a Gaussian to a bunch of images, like just bang off like one or a couple commands. This is a really easy guide to use. So you can just search for it. I think it's just macro. This one's a little bit harder to search for because it's this called macro ... but it's this process batch option that you want to use. So process batch macro. So if you open that up, then you get this window, the batch process window. So what it does essentially is it prompts the user to ask them for an input directory. So where are all your images that you want to process? It asks you for an output directory, so selecting a place to put all the results. And then it's asking you the format that you want to use. So you can save it in pretty much whatever type of format you want, but we recommend saving things as TIFFs to preserve the metadata. And then you can just copy and paste your code right in. Here, this is just the default that I had. That's pretty much what we did before, right? Gaussian, then we applied a threshold to image, mask, watershed, analyze particles. So actually, I could run this just quickly for you. And process. Oh, I have to do that again. I should have indicated. My input folder is this guy. This holds all of my images. My output folder is this output empty guy, and process. Right, okay, so there were a couple issues with something, I don't know, but I mean, it's gonna just run that macro then, and then save it. Save the processed images in that folder, okay? But I think given the work that we've put in today so far, that we can do better than that. We can actually script something a little bit more flexible, right? So what we're gonna do is actually use this template. So again, we include this template in the script editor. So you guys can go back to this whenever you want. So this actually, let's open it right away. So this is in templates. So in this, open the script editor. Then it's under templates, ImageJ1, examples, process folder, image J1 macro. And I think you can also open it. No, you can't. Okay, so let's just do it via the script editor like it said. I can't think off the top of my mind. So left bracket, templates, so that was image J1, examples, process folder, and we're going to just open the macro version. But there's also another one in here in Python. So for any of you who are interested in or can script in Python, there's another example. And there's tons of templates in here. You can just like search around and see what would be useful for you. I'll make it bigger. Okay, so essentially, don't stress too much about what every single little line of this code is doing. I'm just going to walk you guys through it right now, right? So it's kind of similar setup to like the little interactive window we just opened, this batch process window. So instead this time we're using those script parameters. So we have two that are calling for directories. So we have one, we're asking the user to indicate an input directory, okay? And we'll save that input directory in this input variable. Then we ask them for an output directory, so where do we want the data to go to, which is this output variable. And then we're asking them for a file suffix. So what types of files are you interested in looking at? So in this case, we're just using a string, okay? Because it's just looking for those letters that are at the end of your file. And we're looking for TIFF files in our case. All these example images are TIFFs, .tiffs. Okay, so you can change that depending on your file type as well. So again, the script parameters have to come at the very, very top. And then we have another comment called macro. This is a macro template to process multiple images in a folder and subfolders, actually. So what we do is we have two functions here that we've written. We declare them with function, this function call. So we wrote actual, like, you know, there's the print function, those other functions that we use. This one, you can use this format and write your own functions to do something specifically. So this one's called process folder. So this is the first call into the code. It's calling this process folder function on our input directory. Okay? So basically what this is doing is using a for loop, for loop to actually run through and process your individual images. So what it does first, it goes into this function, it gets the list of all the stuff that's in that folder and saves it, okay? And then we're going to move through each item in that list, right? So basically that's kind of storing a length for us, a number of items in there. So in this for loop, we're starting at 0, and then you can either start at 0 and say less than the list length, or you can start at 1 and then say less than or equal to, okay? So don't worry too much about that. So we're saying for each item in the list, for as long as the list is, we want to see, okay, if it's a directory or if it's a file, the file type we want. Okay, so let's say it's the file type we want. So if it ends with that suffix that we told it to have in the beginning, so that .tiff suffix, that string, then we want to call this other function called process file. And that's actually a function that will have all of your macro code in it, your script. So in our case, we're going to segment and count and measure those nuclei, okay? Just as we did before when we built that script in the beginning. So this is actually where you would just copy and paste that code, okay? So as long as it's a TIFF image, we want to process it. But then the other option is, so in this for loop, it's also asking whether it's a directory or not. So if it's another folder, then we need to search within that folder, right, for TIFFs. So that's essentially what it's doing, because it just calls the same function again, okay? To then, again, search for TIFF. The end goal is to actually make this call process file for any TIFF image. And by doing this subcall of this function, process folder within process folder, we're just making sure we're accessing any subfolders that might be hidden inside, okay? So it makes it a little bit more complicated, but don't stress, okay? Because I actually created for you guys a sample script that you can actually copy, and that's what we're going to do now. We're going to copy and paste and put it into the script editor. So this is an example script that will count nuclei in multiple images in folders and subfolders, right? So I use that template that we just opened here, this process folder template, but I inserted the same code that we used before for segmenting our cells. So just copy and paste this, all this code. Actually, I'll just make a new window, so that just, we'll just keep the original process folder in there, and I just opened a new. So if you activate your script editor, you can actually go File, New Script, and then just paste it in. And right now it's not color-coded, right? So what do we need to do? Select a language, exactly. So let's select image J1 macro. So all the stuff at the top is the same as for the template, right? You call this process folder function. It's going to search within our folders or subfolders for TIFF images. And then when it finds a TIFF image, it's going to call this other function process file, like we just said. But this time, what we're going to do is actually segment stuff and measure, okay? So we're just going to walk through step by step. But this shouldn't intimidate you too much because we've already seen this code before, okay? So again, setting batch mode to true prevents windows from opening, right? So that's just going to be handy when we're batch processing 5 different folders, not having ROI manager and all these masks popping up as we're running it. So what we're going to do too is open the image using file formats. Now before we did that manually, but if I just didn't want to like freak you guys out right away, but I will freak you out now because it's a bit of a long call, function call that's in there. So if you actually record it using the macro recorder and open something, import something with bioformats, you get something that's formatted like this. And all you need to do is concatenate the input directory. So that just tells you where, it's a string that basically says where in your computer the folder is located. And then file is just the name of the image, okay? So you could even change that to image, would make more sense. Okay, because what we're doing here, this call, this process file call, is working in your input directory. It needs to know your input directory, your output directory, and then that file, so that image. And in this case, it's indexing into the list of items that are in the folder. These are all weird, scary words, but don't stress too much. Just follow this syntax for now if that's like, if you find it overwhelming. So you just need these 3 things to call this function. And then here, actually, when we call it, we actually kind of rename it to file, a different variable name, that's all. So that actually equals this list I, okay? The value that's held in there is file now, and which is the name of our image. Okay. So then again, we're going to save the ID of the original image. We're going to duplicate it, and then work on the copy, right? So now we're just doing the same exact thing we did before. We apply a Gaussian blur with a sigma of 2. We auto threshold, default dark, create the mask, watershed. And actually what I like to do, I added this code in here because I find it very helpful. Whenever I do this kind of segmentation workflow, I always save my masks. It's just a good idea in general to do. So that's why I did the save function, because I'm saving the binary output, okay? So that's just a little extra gift that I've given you in this code. Then we can run our analyze particle. We select our original image again, and then we want to overlay our ROIs, so we show all with labels. Now we want to measure, so we deselect and then measure on the original image, okay? Now, it's also very helpful to save our ROIs. So I didn't actually show you, if in the ROI manager window, like when we had that little ROI manager popped up, you can actually save your ROIs. I'm sorry I didn't tell you this before, but you can save your ROIs as a zip file, which is also good practice to do. Because if you create them, you should save them, because you also want to, like, maybe one day you want to make sure if you're doing a big batch process, okay, does my image 120, do the ROIs like line up with that original image, just making sure that you're checking everything, right? So we save that as a zip file. So I'm saving it to the output folder for each image, okay, and I'm just tacking on the name. I'm just using the name of that image and then tacking on the zip, the type of, like, the thing that it is. It's a ROI, which is a zip file. And then I clear the ROI manager out so we can go on and process the next image. Okay, so as long as you guys have that folder of images, you should have a folder that I told you in the very beginning to download. You should have a folder with 5 different TIFF images inside, right? So this one's called C3, the folder's called C3JW in my case. I don't know if you guys renamed it, but I'm going to create just an empty folder called output. I mean, again, it can be called whatever you want. So it's just an empty folder I'm going to put on my desktop, and we're going to run this code, and I hope it works. It worked the last time I did it, so let's hope it works. It's okay? So just to show you guys like what happens. So again, because of our beautiful, wonderful script parameters, we get this prompt box asking us for 3 things, right? 2 directories, so @file script parameters, and then a string, so @string parameters, which is in our case the suffix .tiff. So I'm going to make sure I'm selecting the right input folder. So my input images are within this folder, so I'll select that folder. My output directory, I have that empty folder called output. And then I'm going to just process those files that are .tiff, okay? And it should go. So it's accumulating my results. And that's correct. It should have 128 nuclei in the end. You should get 128 in total. But what's great about this is because of the other things, if you actually open your output folder, you'll see that, one, we saved those binary image, right? So if you open those, oh, it's just opening in preview. You can see, okay, like these are watershed, these are clipped, so this mask looks pretty good, and you can overlay it too with the original image if you want, and then you've got all your ROIs saved in your zip files. So in your ROI manager, you can go to open and just open this zip file directly, and all those ROIs will get fed in, and you can overlay them. Okay, and I threw in one more goodie for you called all results. I saved you guys a .tsv file, so that should be Excel compatible, and actually did that at the very end. So did you see when we were running the script, all the stuff was getting printed out into the results window? Well, when we finished processing each file, what I did at the very, very end to save all of the data, I did the save as function call. So I saved what was in the results window into the output directory, and I called it allresults.tsv. So I saved this guy for you. So if you open him, you can open in Excel. Well, it opens default in text editor, but that information is there too. So I'm hoping you guys can at least take this framework with you. We've got something that you can now modulate, change a little bit, spice it up for your particular batch processing needs. But at least you have a skeleton of something that's working. Did you guys run it? Did it work for you? Yeah? Okay, cool. That was the goal. And that's it. We were really early, actually. So again, there's some helpful tips and tricks that I tacked on the last slide. And when in doubt, go to the forum, ImageJ forum. So for those of you who were not here yesterday, the ImageJ forum is an amazing place to ask experts in the field for questions. And don't be shy, even if you feel like this is a super basic beginner question. If you've got a macro and you're like, I'm running this and I don't know why it's not working, you can copy and paste your code in there too and ask us. Sometimes it's something small that you just don't see because you've been staring at it for hours, okay? So just go to the forum and lean on the community. So, okay, do you guys have any questions? General questions? Are you feeling good about this? You feel like you can actually like go home and try stuff and do stuff? Yeah? Sweet. Otherwise, we're done. We'll stick around for a little bit. So off camera, okay? And I'll turn the mic off so it won't be recorded. So if you do have questions,